Here's the answer for the day 3 bell work. Let's see what you can do with fractions. Simplify each. So this bell work deals with numbers called fractions. If you look at question A, you'll see some fractions. This number here is the fraction 3/4. This number here is the fraction 1/4. The operator is addition. Now fractions can be more challenging to work with than integers because fractions show relationships between two numbers. The fraction 3/4 is showing a relationship between 3 of something and 4 of something. A fraction like 3/4 can refer to a portion of an object. Let's say we have a round pizza separated into 4 equal-sized slices. 3/4 of the pizza is this much of the pizza. The fraction 3/4 is used to represent a certain amount of a pizza. But the number 3/4 can also refer to a comparison between two different amounts. For instance, one person could have 3 chocolate chip cookies, and another person could have 4 chocolate chip cookies. To compare how many the one person has to the other, you can create a ratio, which is the fraction 3 cookies compared to 4 cookies. The same number 3/4 is used for two entirely different contexts. One is a single object where we're representing a certain portion of that object. But the other context is two separate counts, 3 cookies versus 4 cookies. Sometimes when performing operations with fractions, it's easiest mentally to think of the first situation. Other times, it's easier mentally to think of the fraction in terms of the second situation. And sometimes it's easiest just to use memorized rules for performing operations with fractions. Question A, 3/4 plus 1/4 would be 4/4, which is equal to 1. In this problem, because the denominator numbers were the same, 4 and 4, I was mentally thinking of the problem in terms of that first example about the pizza. If I have 3/4 of a pizza and then in addition another 1/4 of the pizza, I have in total the entire pizza. Question B, the numbers are 1/3 and 4/3. The operation is addition. I recognize these numbers as fractions, and I'm interested in what the denominators of the fractions are. In this case, they are the same. So I could mentally think of this in terms of that first pizza example. 1/3 of a pizza plus 4/3 of a pizza is in total 5/3 of the pizza. 5/3 of a pizza is like having one whole pizza and an additional 2/3 of another pizza. Now question C is still about adding fractions, but because the denominators of the fractions are not the same, this is a 5 and this is a 10, it's not so easy to use that pizza example to mentally conceive of the problem. Here, using a memorized rule is probably the more efficient way to simplify the problem. The rule works like this. Because the denominators of the fractions are not the same, you need to make them the same. A 5 can be turned into a 10 by multiplying by 2. If you make the decision to change the denominator by multiplying by 2, then you change the numerator by multiplying by 2. This transforms the fraction 3/5 into the fraction 6/10. Now the math expression is about adding fractions, and the fractions do have the same denominator. If you have 6/10 of a pizza, and in addition 1/10 of the pizza, you have in total 7/10 of the pizza. Question D. We can see immediately that this is fractions, and this involves adding. Are the denominators the same? This denominator is a 7, and this denominator is a 5. They're not the same. The memorized rule to add fractions when they do not have the same denominator is to perform operations that will transform the fractions so that you do end up with the same denominators. I can't turn 7 into 5, nor 5 into 7. However, I can turn 7 into 35 by multiplying by 5. And then you would also multiply the numerator by 5. I can turn 5 into 35 by multiplying by 7, and then also multiply the numerator by 7. 4 times 5 is 20 over 35. 2 times 7 is 14 over 35. Now that the denominators are the same, the fractions can be added. 34 out of 35. Question E, 4/7 plus what number is equal to 6/7? The answer is 2/7.